All right, in this video, we are going to generalize 1 over 1 minus x, e to the x, sin of x, and cosine of x for Maclaurin polynomials. And then we'll eventually relate that whenever we talk about power series and representations of them and all of that good stuff. All right, so we want to write a third-degree Maclaurin polynomial for f of x is equal to 1 over x, then generalize our findings for an nth-degree Maclaurin polynomial. I'm going to rewrite this as 1 over 1 minus x to the negative 1, just so that I could use power chain power, whatever you want to call it. Since this is a Maclaurin polynomial, this means that we are centered at 0. So I'm going to have f of 0. Okay, in my first term, that's just going to be 1. Great. Since I have a third-degree polynomial, I'm going to take my derivative into the third one. So my first derivative is going to be negative 1 minus x. But then watch out, we haven't really done this yet, but we have to use chain. In this case, we have a negative 1 as my derivative inside, so make sure that you have that negative 1, which eventually becomes positive 1 right here. That's my first derivative. My second derivative is going to be negative 1 minus x to the negative 3. But remember that I have chain, aka negative 1, which makes this a positive 2. And then my third derivative is going to be negative 1 minus x to the negative 4. But then watch out. Once again, I have a negative x, which means a negative 1 derivative, which means this is going to be positive. So that gives us my 3 derivatives. I'm going to go ahead and substitute n0. And lucky for us, this isn't going to be too hard because if this is 0, this is just going to be 1. 1 to any power is just going to be 1. So I have 1 right here, 2, and 6. Okay, writing this, I'm going to have my first term, which is 1. My second term, which is going to have my derivative term of my first derivative term. That's going to be 1x. Then I'm going to have 2x2 over 2 factorial. And then 6x to the third, 3 factorial. Now, I'm going to go ahead and simplify this so that you could see what's going to happen. I have 1 plus x squared, 3 factorial 6. I have x to the third power. Interesting. If you want to do the fourth degree, I'm going to do f of 4. The fourth derivative, that's going to be negative 24. 1 minus x to the negative 5, or positive 24. This is going to be 24. Which is going to be x to the 4th whenever I do it, because this is going to be 24x to the 4 factorial. If I'm going to generalize this, I have 1 plus x squared plus x to the 3 plus x to the 4, plus x to the n. Interesting, right? I know. Magic. So this Maclaurin polynomial of 1 over 1 minus x, make sure that you memorize that's going to be the same thing as 1 plus x squared plus x to the third plus x to the 4th plus x to the n. So that's going to be one of your special polynomials that you need to memorize. And of course, you're going to have to memorize e to the x too. So let's go ahead and do that. Pause the video, do e to the x. This one shouldn't be that bad, hopefully. Because the derivative of e to the x is just e to the x. That's going to be easy peasy lemon squeezy. And then see if yours is correct. Right, to e to the f of 0 is e to the 0, which is just 1. The first derivative is going to be e to the x. The second derivative is going to be e to the x. The third derivative is going to be e to the x. The fourth derivative is going to be e to the x. And since I'm plugging in 0, all of this is going to be 1, 1, 1, 1. Crazy, I know. So now I have my first term plus my derivative, so 1x plus 1x squared over 2 factorial plus 1x cubed 3 factorial plus 1x to the 4th 4 factorial. If I continue doing this, then my nth degree is going to have x to the n factorial. So this one is also another one that you will need to memorize in terms of the Maclaurin polynomial of e to the x. So that's going to be 1 plus x squared over 2 factorial, x cubed over 3 factorial, x to the 4th over 4 factorial, and then x to the n over n factorial. P to the x. All right, number 9, we're going to do the same thing, except we're going to be using sine. So f of 0 of sine starts at the midline, so I'm going to have 0. The first derivative of sine is going to be cosine. The second derivative is going to be negative sine. The third derivative is going to be negative cosine. And then the fourth derivative is going to be sine. All right, if I'm going to plug in 0, f prime of 0 is going to be 1. F double prime of 0 is going to be 0. The third derivative at 0 is going to be negative 1. And the fourth derivative at 0 is going to be 0. So now I have 0 plus 1x plus 0 x squared 2 factorial. I'm writing that just for simplicity. Plus negative x to the third 3 factorial plus 0 x to the 4th 4 factorial. And if I were to simplify that, I'm just going to get x minus x to the third 3 factorial. Now, you might not see a pattern just yet, but let's continue with the 5th derivative and the 6th derivative using what we know. Remember that this right here will repeat itself. So the 5th derivative, aka sine, well, that's going to go back to cosine. That's going to go back to positive 1. So my 5th derivative is going to be plus x to the 5th 5 factorial. My 6th derivative, well, that's just going to be 0, so I really don't care. My 7th derivative is going to be negative 1, so I'm going back to negative. My 8th derivative, 0. My 9th derivative, I have positive 1. And that's what we have so far, ... Now, you'll notice that this right here, we're alternating signs, and we're only keeping the odd degrees. Interesting. So, if I were to probably make a generalized nth term, let's think about how I could do that if I'm focusing on the odd degrees. And we'll think about why it kind of makes sense. All right, since we are alternating, I'm going to have negative 1. But now let's think about my power. This is my first term. It is positive. So I'm going to have a negative 1 and plus 1 to make sure that this exponent is positive. Okay. Now, as I look at this, I could say x to the 1, and I could say 1 factorial. If I look at this, I have an odd degree. And remember that the definition of an odd number is going to be x to the 2n plus 1. Just kidding. Let's do minus 1. Now, there's a reason why I'm doing minus 1 is because if I'm starting at the first term, then 2 times 1 is 2. 2 minus 1 is 1. So that's why it should be 2n minus 1 instead of 2n plus 1. Now, same thing with the factorials. 1 factorial, 3 factorial, 5 factorial, 7 factorial, 9 factorial. That's going to have the same thing as 2n minus 1 factorial. And if I were to think about this, again, my first term is 2 times 1, which is 2 minus 1 is 1. My second term is 2 times 2, which is 4. 4 minus 1 is 3. My third term is 6 minus 1, which is 5. My fourth term is 8 minus 1, which is 7, and so forth. So this is going to be the generalized formula that you will need to remember. In order to remember this, think about how sine is an odd function. So since sine is an odd function, we're going to have odd exponents. And if that made sense, thinking about cosine and how cosine is an even function, we probably might be seeing even exponents for cosine. Let's see if that's true. All right, so we want to find a fourth degree Maclaurin polynomial for cosine. Same thing. Well, at cosine, we are starting high, so I'm actually going to start at 1. My first derivative is going to be negative sine. My second derivative is going to be negative cosine. My third derivative is going to be sine. My fourth derivative is going to be cosine, and then, of course, I'm going to start repeating myself. All right, so the fourth degree Maclaurin polynomial is going to be 1. Well, first, I probably need to figure out what's happening at 0. All right, anytime I see sine, that's going to be 0. That's going to give me that right there. So now I have 1 plus 0x to the 1 factorial, minus 1 x squared 2 factorial, plus 0x cubed 3 factorial, plus 1x to the 4th 4 factorial. And if I were to simplify that, I'm going to have 1 minus x squared 2 factorial plus x to the 4th 4 factorial. Now, obviously, that's not a lot. And if I were to probably think about the fifth derivative and me going back, that fifth derivative is going to land at 0. My sixth derivative is going to be negative. My seventh derivative is going to be 0. And then my eighth derivative is going to be positive. So once again, I'm going to have the alternating signs just like number 9, except this time I'm dealing with the even degrees. So once again, I'm going to have negative 1 to the n plus 1 power. Since we're still positive, my first term is still positive. And then I have x to the 2n, since that's the definition of an even number. Then I have 2n factorial. All right, now obviously we are starting at 1. So whenever we are doing this right here, this kind of tells me that this is my term 0. So n starts at 0. If I want n to start at 1, then let's probably think about how we could do that in terms of this being an exponent of 0, this being an exponent of 2, 4, 6, and 8. Well, that one's kind of easy because we're just going to do 2 n minus 1 right here. Or technically 2n minus 2. So let me actually write it like that. 2n minus 2. And then this one, same thing, 2n minus 2 factorial. That's if I'm starting with my first term. Obviously, this one right here works, and I kind of prefer this way here, just so that it's simpler for you. All right. In the next video, we are going to talk about the FRQ. There are two very similar in terms of this lesson right here.